Hello everyone. Hi, welcome to Ask IITians. This is lecture number 4 of Triangles chapter from grade 10. Yes, so we have already completed 3 classes and we had talked about similarity of triangles, congruency, then we also talked about basic proportionality theorem, its converse, and in the last class we had talked about very interesting concepts, that is SSS test, SAS test, and ratio of areas of triangles, right? So now in this class today we would be talking about some more important things related to triangles, right? And as I have been saying repeatedly, this chapter is very much important from your board's perspective. This is very much important from your board's perspective. It is of 9 marks, right, with options. So let's quickly see that what are the things which we are going to cover in today's class, right? So let's just have a brief understanding. That is, we are going to cover the very popular theorem and very important theorem in today's class, that is Pythagoras theorem, and we will be also talking about its converse. So some more important results we would be talking about from Pythagoras theorem, right? So our uh, talk for the day, it would be just Pythagoras theorem, right? So first let's state, so you all can see that he was a famous mathematician, Pythagoras theorem. I mean, he was a very famous mathematician. Pythagoras, this theorem is named after him, and he was from 569 to 479 before Christ. Yeah. So let's quickly say what does the theorem states. It states in a right angled triangle. Okay, so now we are talking about specific triangles only. That is, we are only talking about right angled triangles and not any random triangle, because so far the theorems which we have stated, they had any triangles, any two similar triangles, but here we are restricting ourselves to right angled triangles. Okay, the square of the hypotenuse, what is the hypotenuse? It is the side which is opposite to 90 degrees. The side which is opposite to the right angle is called as the hypotenuse, right? So in this triangle ABC, AC is the hypotenuse, right? The square of the hypotenuse, it says. So here we would say AC cos square is equal to the sum of squares of the other two sides. Sum of squares of the other two sides. So what are the other two sides? AB square plus BC square. Sum of squares. Sum of squares and not squares of sum, because some students might mistakenly understand it as AB plus BC whole square. This is not it, because this means square of the sum. We are talking about sum of the squares, right? So let's now quickly see that what is he saying in the next part. In the next part it says the sides of this triangle have been named as perpendicular, base, and hypotenuse. So we already know that this is the hypotenuse, right? And this is known as the base of the triangle, whereas this is known as the perpendicular, right? So these are the things which we need to know. So Pythagoras theorem says if there is one angle which is 90 degree in a triangle, then you can clearly say that AC square is equal to AB square plus BC square, right? This is known as Pythagoras theorem. Okay, so let's see its proof, because some students might say, so you just told us that this is this Pythagoras theorem, how did this come, how did we derive? So let's consider that we have triangle ABC in which measure angle B is 90 degrees. Triangle ABC, what do we have to prove? As we saw, AC square is AB square plus BC square. So we would make a construction in this case, that is, we would be drawing segment BD, segment BD which is perpendicular to the hypotenuse. Segment BD is perpendicular to the hypotenuse, right? Now what does this A dash D dash C means? It means betweenness, that is D is in between A and C. You have to draw perpendicular in such a way, right? So let's start with the proof. It says in triangle ABC, segment BD is perpendicular to the hypotenuse. Because this is the reason for this is construction. We just now drew this segment. Then we would say that if these two triangles, that is triangle ABC and triangle ABD, the bigger triangle and the smaller triangle are equal, therefore they would be similar in nature because of right angled triangles, because one angle is 90 degree and the other angle is common angle A, right? You would say, and angle A is common to both the triangles, right? To both triangles. So here you have triangle ABC is similar to triangle ADB, right? So therefore the ratios of the sides would be equal, that is AB by AD is equal to AC by AB, right? Because CPCT, corresponding sides of similar triangles, corresponding parts of similar triangles, CSCT or CPCT. So from here we get AB square is AC into AD. AB square is AC into AD, right? Similarly, triangle ABC is similar to triangle BDC, ABC, BDC. So you would say BC by DC is equal to AC by BC. Therefore, BC square again would be equal to AC into DC. Now, why can we say again these two triangles are similar? Because angle B is common and one angle is 90 degrees, right? So therefore BC square. Now you would consider that AB square plus BC square can be written as AC into AD plus AC into DC, right? If you take out the AC common, we get AD plus DC. What do we mean by AD plus DC? We can clearly see that AD plus DC will give us AC, which implies AC square. So this is how we prove Pythagoras theorem, right? So it's a very popular theorem. It's a very important theorem because you would be asked many questions based on this theorem. And why is it important to study this theorem is like, you can say, for example, if you are coming to coachings for learning, let's say this is an offline coaching and you're coming to learning from your home, and this is your home and this is your uh, coaching, right? So if you want to come here, you would say let's start your journey from home. So you usually adopt the route from A to B directly, right? But what happened that one common day this bridge was not working, so you said that I would take the longer route, right? So you took the longer route. Then after some days you said that this is going to be a very long, so I'll try to find a shortcut way which is shorter than the other way. So then you said, okay, this is your new route. So in all the cases, how do we come to know that what is the shortest distance possible between A and B? So for that, we would say we need to connect A and B by a straight line with the help of a right angle here. So when you connect with a right angle and you can get the distance, so you would say that Pythagoras theorem is really helpful in getting this shortest distance, right? So this is about the application of Pythagoras theorem and why is it important to study. So now let's quickly solve a question based on this, right? So it says a person has to walk 100 meters to go from position X in the northeast direction to position B, right? So position A is this, right? This is your position A. The person has to walk in northeast, so we know like northeast would be here, right, to the position B, and this is our position B. uh, from position X, this was X, and then to the west of Y, so this was your position Y. So to reach finally, west means to the left, right? This is your west, to reach to the position Y, right? the position Z is situated at the north of X, which means X and Z are in a same line. They are north and are in a vertically same line. So this is your Z, and at a distance of 60 meters from X. So here your XZ distance is 60 meters. And what was this 100 meters? Has to walk 100 meters to go from position X to position B, that is to the west of Y. That is, this is your 100 meters XY. So he's asking what is the distance between YZ, the distance between Y and Z is being asked, right? So you would say that this is a right angle because they are in a straight line. It is given in the question that the position Z is situated at the north of X, right? So you will say, let's use Pythagoras theorem. So you would say xy square is equal to xz square plus yz square, right? So this will give you basically the distance between y and z, and that is how we calculate, right? So let's quickly move to next part. Now we would be talking about converse of Pythagoras theorem, right? Converse of Pythagoras. So we would be saying that why the converse is also equally important, because now you have the relation between the sides. So if the sides are special, that is if you have a triangle ABC, right? If you have a triangle ABC, now you don't know in prior, you don't know at prior whether this triangle is a right angled triangle or not. But you know something else, that is you know that the sum of squares of other two sides is equal to sum of squares of the first one, which means here let's say that AC square is AB square plus BC square. This is given, right? And what can we say then? The angle opposite to the first side, that is angle opposite to AC, angle opposite to AC is equal to 90 degrees, is a right angle, right? So this is how we would be talking about its converse. Now how do we prove this? That is angle B is equal to 90. We have to prove this. What we are given, that AC square is AB square plus BC square. So here we have a triangle PQR in which PR square is PQ square plus QR square. This is given. This is the triangle PQR. This is given to us, right? What do we have to prove? That angle Q is 90 degrees. So in that case, we said construct a triangle XYZ, right? Construction. This is your construction triangle, right? XYZ, such that xy is equal to pq, yz is equal to qr, and angle y is 90 degree. We have constructed a triangle such that xy is equal to pq and qr is equal to yz, right? So now we would say let's apply Pythagoras theorem in triangle xyz, because we know that one angle is 90 degrees, that is measure angle y is 90. So we can use Pythagoras theorem in our constructed triangle, mind you, not in the given triangle, right? So measure angle y is 90 degrees, therefore xz square is equal to xy square plus yz square. Now we know that xy is equal to pq and yz is equal to qr because we have constructed this triangle. So we can say that xz square is equal to pq square plus qr square. But we are given something important, that is pr square. So pr square is equal to pq square plus qr square. Now from equations 1 and 2 we would say let's equate, right? Let's equate both of them. So xz square is equal to pr square, therefore pr is equal to xz, right? This is what we can say, that PR is equal to XZ. Now in triangle PQR and triangle XYZ, we can say that PQ is equal to XY and QR is equal to YZ. What is the reason for this? By construction, right? And if we name this equation 3, we would say PR equal to XZ from 3. Therefore, the triangles are now congruent and not just similar. So therefore, measure angle Q is equal to measure angle Y is equal to 90 degrees. Therefore, converse is also true. That is, converse of the Pythagoras theorem is also true in this case. This is what we understood. Now let's see some couple of results with Pythagoras theorem. What does it say? Pythagoras theorem is useful to find sides of a right angle triangle. If we know two sides of a right angle triangle, we can find the third side, right? By the Pythagoras theorem, it follows that the hypotenuse of this triangle has length is equal to c times under root a square plus b square. You all can see this triangle with the help of three boxes. The space in between the box is forming a right angled triangle such that one box is kept perpendicular to the other. So in that case, we would say AC is your, this C is your hypotenuse, right? So you'd say C square is equal to A square plus B square, right? So hypotenuse length C would be equal to square root of A square plus B square, right? So from using Pythagoras theorem, we can get the length of the hypotenuse, right? So now let's quickly solve this sum, right? It says it's a very exciting sum. It says the height of the two building is 34 meter and 29 meters, right? So there is this one building A, B, C, D, E, and the other building is B, C, D, E. Now they are kept one on the other, and we say that we have the heights of them. So if the distance between the two buildings is 12 meters, so we have this distance DE as 12 meters, right? What we are interested in, find the distance between their tops. So what is the top of this building? The top is here D and the top is here A. So we have to find distance AD. How can we find this distance AD? We would simply use, that is, Pythagoras theorem, because we now have that AD is equal to AD square is equal to AE square plus ED square. We have AE as 5 and ED as 12. So there is no need to do anything, because you can directly say that your AE is just 5, because AE will be equal to AB minus BE. So AB is 34, BE is 29, which is given. Therefore, AE would be 5 meters. So therefore, AD square will be equal to AE square plus DE square, right? So from here we can say that AD square will be equal to AE is 5 square plus DE is 12 square. So this is 25 plus 144 is 169. Therefore, AD will be equal to 13 meters. I hope you all understood this, and so and I hope you had good understanding and real life understanding of Pythagoras theorem. So in the next class will be the very important class of triangles, wherein we would be talking about angle bisectors and some theorems on midpoint theorem. So till then, stay safe and enjoy.